Hey, what is up guys? My name is Cherno. Welcome back to my game engine series. So last time we talked about creating a separate sandbox 2D layer. Check out that video if you haven't already. And the purpose for that was basically just to prepare ourselves for doing 2D rendering. I want to get Hazel into a state where it will be as clean and as simple as possible for us to just jam in 2D rendering and be able to test everything that we need to test as a result of implementing that. So in other words, when you start working on a new feature in some kind of code base, it's really good to try and create some kind of test environment for that so that you're able to cleanly and easily kind of see if what you've done actually works or not, especially when we're dealing with something like C++ and we need to watch out for memory leaks and any kind of other like little things that you wouldn't have to necessarily do in other languages. I think that it's important to create as clean of an environment as possible. And the thing with that as well is that because I guess, we kind of have Hazel at a spot here where it is relatively clean and simple. I don't think there are too many bugs at all. Most of you guys have fixed that using pull requests, which is fantastic. But there are still more things we can do, right? And for those of you watching who really want to contribute, or not necessarily contribute, but also kind of learn, I guess, and take Hazel and actually make it a little bit your own and not just copy everything I'm doing here or on GitHub, but actually kind of implement this into your own engine. There are so many more things you could do before you start 2D rendering. One thing that comes to mind immediately pretty much is like profiling and like memory tracking, right? So when I'm doing anything like that, I have no idea if there's a memory leak in Hazel or not. I can look at Visual Studio's diagnostic tools. So like you can see Hazel is running over here and in the background I can kind of check out the diagnostic tools that Visual Studio gives you, and we can see that it's using about 100 megs of memory, and that's not, or 80 megs of memory, and that's not kind of increasing like at all. In fact, it's kind of decreased a bit. So there's clearly like no evident memory leak, or at least not a big one. So there are tools that Visual Studio provides, and like profiling you can do in Visual Studio as well, but that stuff is not stuff that I would necessarily rely on. Not because it's bad, but because Visual Studio is not going to be the target environment for everything, right? When Hazel eventually supports Mac and Linux, when Hazel eventually might support Android, iOS, that kind of stuff, what you want is in-engine tools to do things like that. So for example, I want to see what the memory usage in Hazel is like, and specifically Hazel's memory usage, right? So there's all this overhead from the runtime library or the runtime, I guess the C standard runtime, that kind of stuff, where we kind of to create a Windows application and to do all of this stuff, there's all this kind of overhead that you don't really see. But specifically from Hazel, for example, like I've created vertex arrays, but all of this kind of, I've got my sandbox 2D layer. I want to know how much memory I've used up in actual Hazel client space. That kind of stuff is important, right? And seeing graphs over time. Adding something like that is really important, and one of the ways that you would do that is by actually taking memory allocation into your own hands. So in other words, basically, especially in debug mode, passing all memory allocations through your own code so that you can actually both record metrics on those memory allocations, but also in the future make smarter decisions as to where the memory comes from so that you're not hitting the heap all the time. So that's one exercise that you guys could do if you're interested, look into custom memory allocation, but specifically metrics and tracking, and with profiling as well, right? So some kind of timing mechanism that will basically, maybe via instrumentation, where you can maybe add like a macro to each function, or something like that, and it will track how much time was spent inside that function, being able to then visualize that data somehow. Super important, and that's actually something that we'll add eventually whilst adding the 2D renderer, because what we're going to do initially is we're going to implement a naive kind of 2D renderer, something that works but is pretty basic, and it's not going to be terrible, but it's just not going to be the optimal solution. It's going to be a lot more simple though. So we'll do that first, and then as soon as we do that, we'll record metrics from it. We'll see how fast it runs, how many sprites we're able to render. We'll add textures to that stuff. We might even do font rendering or something like that, although I think that'll come later. And then after we have that set up, we're going to look at an optimized kind of 2D batch renderer and how much of a performance difference that makes so that you guys can really see that. And of course, to do that, I'm going to have to add some kind of profiling, which I want to add like custom profiling into Hazel. I don't want to use Visual Studio's profiling tools for that specific example. Anyway, that's kind of the roadmap of what's going to happen. But if you want to jump ahead, if you want something to do right now between these weekly episodes, then check out kind of memory allocation metrics, and then check out some kind of profiling. And I have a video called timing in C++, which also, or benchmarking in C++, I think, or probably both, that will actually show you how to potentially write a little benchmarking thing, but I've got a much more advanced plan, of course, for this game engine series. Anyway, before I continue, just want to thank I was going to say our sponsors for this video, which actually are all of you guys, all of you lovely patrons. Patreon.com/Cherno is the best way to help support this series and everything that I'm doing here on YouTube. Huge thank you as always. I released an exclusive video, I think yesterday, well, based on when I'm recording this video. I released an exclusive video yesterday. I'm going to try and do exclusive videos a lot more. It's only $3 a month to get into that, by the way. And I'm trying to do one a week starting from like now. We'll see how that goes, though. No guarantees, of course. I'm just going to try my best with all this work that I have to do here. But ultimately, you'll also get access to the Hazel development branch, which is like a lot more advanced version of this and basically has like full 3D rendering. So if you're into 3D, you're into that kind of stuff, you don't want to deal with this 2D stuff, which, I mean, is still important and still really useful. Obviously, you'll have to have that anyway. Then you can jump ahead and help support the series as well. Okay, let's just dive in. I don't want to talk too much. The plan is going to be pretty simple. We're going to create a 2D renderer. So it's going to be like a renderer 2D class. It's going to be fully static. We're going to have a go at creating a more static approach to this because I think we have a renderer, but it has some unknown storage somewhere. I'm not sure about that. Renderers in general should be static. I might go over, what I want to do in general is create very generic, non-game engine series specific videos, non-Hazel specific videos that kind of detail, you know, what a 2D renderer is, how to implement like a batch renderer, how to do this, how to do that, you know, font rendering will probably be its own standalone video so that you guys can see how this works outside of Hazel, because the more we build up this code base, the more it's going to be super specific to Hazel. And that's not good for me because, you know, the videos are going to get less views basically, but also that's not good for people trying to implement this in their own engine base, because having all of this Hazel code around it complicates things, because we'll start relying on like layers and, you know, our own kind of library of code essentially. Whereas if someone wants to kind of take that and implement it in their own engine, that's going to be really difficult. So we'll kind of end up having both. We'll kind of end up probably having a pretty lightly explained implementation in Hazel, but then also an in-depth kind of maybe OpenGL series video, or just a standalone kind of video that will cover the architecture and how to implement something from scratch in a standalone video. So that's kind of my plan with these things as we start getting into more complicated matters. And as I mentioned, we probably, like, for now, I'm just going to write all the code. A 2D renderer is not that difficult to implement. So I'm still going to write all of the code in front of you guys. But in the future, we may need to switch to like diffs or just looking through like already written code or something like that, because the volume of code is going to grow and grow and grow, and that's going to be unsustainable. Anyway, let's jump in and take a look at the 2D renderer. Okay, so this is the sandbox 2D class that I was talking about. This is what we've made so far. It's pretty simple. That was kind of the point, to keep it as bare as possible. There are a few things that I still want to fix up, but we'll kind of do that as we go. Specifically this upload uniform float 4, and just in general when we start uploading matrices as well, we're casting that dynamically to an OpenGL shader. I think that what I might do is just have a set mat4 or set vec4, set float 4, whatever, something like that in the base shader class for now, because my hopes was that we were going to implement a material system soon and use like uniform buffers essentially, and in that case we actually wouldn't need to upload individual variables. But because I think that is still far off, and also I think that's a good feature to have for debugging, right? For example, I just want to quickly set a uniform float 4 or a mat 4 or something in the shader without going through a material system or without going through the renderer. It's probably a good idea to have that. So that's kind of a to-do. I'll kind of leave this as a to-do. You know, shader set mat4 and shader, whoops, what am I doing? Shader set float 4, right? So these are two functions that I want to add. So add these functions. Okay, so I kind of want to add these two functions so that we don't have to do the dynamic cast, and thus we kind of fix that. Which will kind of look a lot better. We won't have to include OpenGL shader either, which kind of ties everything to OpenGL, of course, because this includes shader, which includes actually no, this doesn't. Of course, Visual Studio keeps crashing. I need to really fix everything. This happened last time as well. I'm not sure what's going on. I don't even have any extensions installed. Anyway, whatever. The show must go on, as they say. So next time I'll have like a different computer maybe running this. So what we'll do is we'll take a look at, we kind of have this in general. We have renderer begin scene. Let's take a look at that because that's our initial thing. We have scene data here, which is a static kind of scene data kind of struct, which is fine. That's what we have here. That's fantastic. That's kind of the same idea that we'll take and implement in a renderer 2D. Let's go ahead and just start writing the code. So inside renderer, and I'll make sure that I'm in show all files mode because if I'm not, it's going to be a disaster. Yep, I am. I'll add a new item. I'll create a CPP file called renderer2d.cpp, and I will do the same thing for our, let's see here, for our H file. So this will be namespace Hazel, and then we'll have a class renderer2d. Now, this is going to be super static. Super static is something that I just made up on the spot, but basically what super static means is this has zero storage. This does not deal with storage at all. This is going to be a storageless class. There's not going to be any private like static stuff here at all. It's going to just be a set of render commands. That's kind of what you want to have, or at least what I want to have in this case. We're going to have a go at doing it this way, and we're going to see what that ends up looking like. So we'll have static void, begin scene. We know that that's going to take in an orthographic camera. We know it's not going to modify that orthographic camera, so I'll just take it in as a reference. So we'll say orthographic camera, and we'll have to include that orthographic camera. So begin scene we'll have a static void end scene, which I don't imagine will do pretty much anything in a simple renderer scenario. In a batch renderer, it will probably upload the vertex data to the GPU, but for a simple kind of primitive renderer like this, I don't think it will do anything like that at all. And then we'll have our actual, primitive, we'll say primitives. So this is kind of the system stuff, begin scene, end scene. We probably want to have init and shut down as well. Again, it is fully static, so we definitely need to basically have what the equivalent of constructor and destructor will be. Now, there's this huge question that I get asked very, very often, which is why static? Why have a renderer be static? And you don't have to have a renderer be static. This is not something that's like, your renderer is not going to work unless it's static. The whole concept of static and object and instantiation and object-oriented programming and all of this stuff, that is all a language construct. What matters in the end are the actual OpenGL calls and data transformation, data management stuff that you're actually doing inside functions. If you go back to the root level and you think about what object-oriented programming is, what is a class, what is a member function, it's just a static function with a pointer to a block of data. That's what it is. That's what classes are. That's how they work. So ultimately, by making something static, all you're doing is saying that I'm not going to have a separate block of data for each class, right? For each instance of my renderer 2D class that I need to point to every time. You're saying that I will manage that block of data myself. That's what you're doing, which is a different way to think about it, of course, because that's not typically the way that you would think about it if you're just learning object-oriented programming, or you're just thinking about, everything has to be a class, everything has to be that or that, right? But it's true. And I think that as you kind of probably get more into, as you become a better engineer, I'll say, and obviously I don't know what level you guys are at, so if you're past this level, this is going to be a waste of time for you. But for those of you who are still kind of getting into software engineering maybe, or don't have that much experience, or are still wrapping your heads around programming and C++ and how that all works, in the end, obviously, all we're doing is we're executing CPU instructions. All of these constructs that we see here, like classes, they help us organize our code a little bit better and make certain things easier, right? Because they take some of the management stuff away from us and essentially convert it into syntax sugar. That's what they're doing, right? But at the end of the day, what are we doing in the 2D renderer? We're executing OpenGL commands, right? Not necessarily all we're doing. I mean, we have to do potentially some kind of maths as well. But ultimately, what are we doing? We're managing some kind of data set, which is our scene, essentially, right? And then we're executing OpenGL commands. We're taking in input data, such as I want a rectangle here on the screen. And then we're basically just saying that, given this rectangle that you've given me with this data, I'm going to, upload this uniform matrix to the shader and then execute a draw call. That's what we're doing, right? That in no way involves classes or anything like that. That is just OpenGL functions that we're calling with data. Now, why is this in a class in the first place? Mainly because it's gonna look better from an API point of view, right? If it's not a static class, if it is like, because this might as well be a namespace, by the way. We could make a namespace called renderer2d. I've made it a class for no other reason, just because it's just gonna look nicer, you know? There's no actual difference. It's going to look nicer, it's going to be a recognizable type, you know, there's not going to be any instances of it, because it's all completely static. But ultimately, and I don't want to get too much into this and confuse you guys too much, but basically what I'm saying is that a renderer2d is something that's global. It's a wrapper over certain GPU render commands. That's what it is, right? The data storage that it has to have is a singleton, in the sense that like you only have one active scene at once. You only have one renderer2d at once. You cannot have, you know, multiple copies of renderer2d. What does that even mean? If renderer2d doesn't contain any data itself, what is another instance of renderer2d? It's nothing, right? It's just an instance of renderer2d would just be a vehicle. I would say, I don't know what I'm talking about right now, to be honest, but it would be like a method, I guess, of calling a function which is going to execute OpenGL commands, which can be arbitrary anyway, because they're not, you know, they're not tied to a specific OpenGL instance. OpenGL inherently is something that's global, right? So it makes sense to make a static renderer because, first of all, you know, the renderer is sequential. There is no such thing as I'm going to begin a scene with one renderer and then begin a scene with my other renderer instance. That's not done, right? You do everything sequentially, kind of consecutively, right? Chronologically, you could say as well. You do everything line by line. You begin your scene, you submit your primitives, you end your scene. You can do this anywhere in your entire code base. It doesn't matter, but ultimately that's the flow of the renderer. That's how it works, okay? So hopefully that little explanation there made sense. Completely unplanned. I was just gonna write the code, but then I started thinking about, you know, other like messages that people have written me and stuff like that. That ultimately what we're dealing with here is, you know, dumb it down to what you're actually doing OpenGL wise here. And then you'll realize that, you know, ultimately I need some kind of data store potentially, because I need to know what the active scene is, maybe, right? I need to have like a specific shader potentially that's bound, right? But ultimately what this is an incredibly kind of static, kind of procedurally programmed, you know, piece of code that just says that I activate my scene, I do all of my necessary stuff, and then I do a bunch of like OpenGL commands or potentially store things in some kind of buffer if I need to for a more advanced renderer. And then I just, you know, execute a draw call. That's what I'm doing. It's super simple. There's no need to complicate it. And there's definitely no need to instantiate a class like this whatsoever. Okay, so for the first thing that I want to do here is basically have a function that lets me draw a quad. So I'm going to say draw quad. Now I could call it fill quad because it's going to be filled in, but I'm not going to really do anything like that. We're just going to have draw quad. We need to think about what we actually want to take in here as far as parameters go. So I'm going to be probably suggesting that we have a vec2, which is our position. Normally you would, ultimately you probably want to deal with both vec2 and vec3. The reason is we can use that third z coordinate for kind of sorting essentially in the z axis. So it's kind of like a z index type thing where you can basically be like, okay, I'm rendering this last, but I want it to be like at the very back of my scene. So I'll set it to have like a position of negative 0.5 in the z-axis. By doing something like this, you can kind of create layering, right? And you can basically control, you can basically create your own layers in terms of like, you know, I'll have a layer at 0.9, 0.8, 0.7, 0.6 negative axis, right? And then 0 will kind of be the center of my scene. And then if I want things explicitly in front, I can render them at like a Z of 0.5, right? Or something like that. Or, you know, the other way around, you know, because I think the way that our projection is set up at the moment is that negative values go towards the camera, right? Whereas positive Z values go away from the camera. So I'll leave it as vector position for now. We probably want some kind of size as well. Typically when you render something like this can be a vec2. This will be size. And then I also want to have a vec4, which basically says what our color is. And again, as I mentioned, it's nice to have a vec3 instead of a vec2, so I'll add this as well. This is the skeleton for our 2D renderer here. So I'll include our PCH, I'll include our renderer2d.h file here, namespace Hazel, and then I'll, was going to use Visual Sys, but I didn't have that installed, so we'll just implement everything manually. Let me see if I can just do that, and then add a bunch of curly brackets everywhere. I could have used Visual Studio to implement the functions actually, now that I think about it, but it's okay, this is not going to take too long. And then the last thing that I need, of course, is that renderer 2D namespace. Okay, cool. So now we have everything. So one of the first things that we need to do for the renderer, we're going to try and blaze through this as fast as possible because the video is already like 20 minutes long. Basically what I want to do is the same way that we begin a scene here and we get a camera and we do all of this stuff, right? This is going to become Hazel renderer 2D begin scene. I will add this to hazel.h as well, and I can't use Visual Studio to open the file, so I'll have to do this. So we have renderer. I'll also have a renderer 2D. All right, so that we have access to this. And so now we have a Hazel renderer 2D begin scene, which is great. And then again, 2D, Hazel renderer 2D end scene we'll have as well. Nothing like submitting here that needs to be done. This stuff as well, gone. You know, we'll keep this around just for a bit because we'll probably need to copy it, but ultimately it doesn't need to exist. Set clear, color clear, that stuff will probably move to the renderer eventually as well. And then really our test here would be something like, we had submit with a particular square, which I wish I didn't remove. So let's see, okay, well it was just, yeah, okay. We did it with like a scale or whatever and with a color. So we'll just say draw quad, and then we'll take in a position. I'll just keep it as 0, a size maybe of, you know, 1 or something like that. And then a color, which I'll set to, let's make this like red maybe, a bit kind of on the red side here, with an alpha of 1. Okay, so we have a draw quad here now that should draw a 1x1 quad. That's kind of what we would expect. Right, so let's go ahead and convert all of this stuff into basically something that we can use in our 2D renderer. So the way this is going to work is I'm going to cut this code here. I'm going to pop it into renderer 2D, into init. And then now you realize that, hang on a minute, we need state, right? We need to have some kind of storage for this. But this is super easy to do and again, does not require any kind of static instances. What we do here is, again, we just have something like renderer 2D storage, right? Or something like that. It ultimately doesn't even matter at all. And you can kind of format this however you like. We'll do something like this to begin with. And then you just have all of the stuff that you need. So for example, ref vertex array, you know, this becomes our, you know, I'll say our vertex array. And then we have, and this may need to like include some things here. Ref vertex array, for example. And I don't know if I can actually call it that because it's the same as a type. But we'll kind of leave it like that for now, maybe. So vertex array, and then, you know, if we don't need a vertex buffer or anything like that. What else do we need? A shader. So, you know, we'll have our flat color shader. I'll call this quad vertex array. And then shader as well will include. Right, and then what we do is we just take renderer 2D, we make this static so that it's kind of, so that it's like unique, I guess, to this translation unit specifically, so that it's not completely global for linkage purposes. And then we'll just call this, what should I call this? Renderer, probably just data. And you can call this data as well, but I've just called it storage. Because I guess that's what it is technically. So we have this, right? It's super simple. We have sData, and then anytime we want something, we just access it. So we just say sData dot, and you can make this a pointer. I've made it just a normal kind of, it's got a bunch of shared pointers. I've just made it kind of a normal kind of stack-based kind of function. It is static though, so it's going to exist for the lifetime of the whole application. So because it doesn't really matter about initializing or like deinitializing this at all, you know, this doesn't run code upon an initialization that needs to be done at a certain point. It's just going to default initialize a bunch of shared pointers, which is obviously trivial and not something we have to worry about. So we can keep it as that. If you start growing this and you have, like, for example, a static array, which has like a bunch of elements in it, or I don't know, you might have stuff here that actually uses up considerable storage and you want to manage that. At that point, you can make this a pointer and then allocate it in a specific allocator or an arena or something like that. But for now, we're not going to worry about that at all. So quad vertex array becomes this, and then, you know, same with here and here, and then flat color shader, of course, would just be sdata.flatColorShader. Okay, so now we're kind of doing something that's a little bit better, I guess. Okay, cool. We're actually, okay, that's fine. Just looking at these vertices, they look fine to me as well. The position will be probably modified using just a matrix in this case, but that looks pretty good to me. I'm just skimming through it. All we have is position, which is probably fine. That's probably all we need for this simple renderer. Okay, let's just see if we can get this to work. So everything else I'll kind of leave as is. Another reason to have init and shutdown, by the way, is because that way you can explicitly like control the memory, because at this point, you know, this stuff is not going to get deleted or released until we actually shut it down manually. So it might actually be worth kind of making this some kind of pointer essentially, and then explicitly controlling the memory. In fact, I think I will do that because I can just see problems being caused in the future. So this is really simple again. What you do is you take this and you just initialize it here. I'll add these parentheses even though you don't have to. We'll take, this now becomes an arrow. So just to be clear, the reason that I don't want to leave it as a kind of automatically managed piece of memory is because in shutdown, I specifically want to delete this. The reason is that shutdown here will, for example, destroy vertex arrays, right? And it's important that this stuff happens because if you look at the destructor and where is this? I have to use this, unfortunately. But anyway, if you look at the destructor for an OpenGL vertex array, right, it will actually call an OpenGL function which deletes it from the GPU. If this gets shut down as a result of this, you know, if this gets shut down, if we look at the renderer, the renderer has to get shut down while we still have an OpenGL context. Otherwise, that code is just not going to run. It's going to crash. So because of that, we need to explicitly actually call those destructors, which is what delete will do. Delete will delete this. The reference will get released. Hopefully nothing else is holding on to it, obviously. And in fact, this could, again, just be role pointers for that purpose as well. They definitely don't need to be refs. They could be scopes. In fact, that probably would be better, just because, you know, they're not going to get passed around anywhere. It's important to think about lifetime for reasons like this. I think I will make this a scope. The only problem is that we don't really support scope. This becomes a huge kind of issue that we'll probably end up talking about later because of the way that the API is structured. But ultimately, my point is that we need to explicitly control the lifetime of this and delete it explicitly, like manually by ourselves, not just wait for the lifetime of the program to delete them, which is what would happen without this being a pointer, because there is certain OpenGL code that needs to run. And obviously we need to guarantee that that happens before the OpenGL context gets released. Anyway, all the Hazel namespaces here can just get deleted. In fact, I think I'll just kind of look at the current selection here. Selection and just replace that with nothing. Okay, cool. So there we have it, brilliant. Okay, so that aside, begin scene will simply upload the camera data as it kind of does before. So if we look over here and we see this kind of, well, what the other renderer did, I guess. If we look at renderer and then look at the begin scene function, you know, it set the view projection matrix. And then that was set dynamically for kind of each shader. If we look at our actual shader that we're dealing with, which is our flat color shader, let's take a look at what this even has. Okay, so it's got view projection, it's got a transform, great. So if we go to, let's see, if we go to back to Sandbox and we look at, for example, this, we'll copy this line of code. And then back in renderer 2D, in begin scene, what we'll do, because the shader is going to get bound once, right, is we'll bind the shader, which is what we're doing here. This will just be S data and then flat color shader. We could just call this shader, honestly, just because it is like that simple. But we'll leave it like this for now. If we look at what we had before, I think we need platform OpenGL shader. So we'll kind of go back here. And again, that is on the to-do list to be removed. And then dynamic pointer cast. Okay, that's fine. All right, so we bind the shader, and then what I want to do is, of course, set or upload uniform mat4, and then this will actually be so view projection, and then this will be the actual matrix, and the matrix being camera get view projection matrix. Okay, so we end up with something like that. And then end scene in this case does nothing, and then draw quad at a particular position, all that stuff. Basically what we'll do is, what did we have before? It doesn't really matter, I think. It's got the color as well, so let's take this. Now, if we set uniforms here, ultimately it kind of is important to make sure that the shader is bound. So what you would do is you would try and bind it again. In the future, what we'll do is this will actually look at what the currently bound shader is and then not call that function again if it hasn't changed. The problem is that theoretically you could begin a scene and then do something in 3D land which would then rebind the shader. This shouldn't happen, but it might. So it's safer to just leave a bind there just before you do anything. But ultimately, again, because that bind can be expensive because it's an OpenGL call, you could cache that essentially and just make sure that if the shader that you bound here is still bound, then just basically ignore this call. And that's also commonly done. Okay, so upload, this will be upload uniform float 4, this will be uColor, and then we'll upload the color here. And then to do the actual draw call, what we should do is basically what we did, I think, in renderer, which was just vertex array bind and then render command draw indexed. So back in here, we'll do this. And again, you can see this is kind of the naive kind of implementation, I guess, where we're actually just taking the quad vertex array, where we're actually just immediate mode kind of rendering everything. But that's kind of step one, I guess, into getting this stuff to work. So let's see, what do I need? I need the render command thing, which I think is just render command.h. Yep. Okay, cool. So there we go. Render command draw indexed, and then this should be the quad vertex array. I'm not sure if we need to bind it though. I guess we do. Draw indexed vertex array. Okay, yeah, sure. So we still have to bind it, which is fine. And then we'll just do draw index, which is fine. Okay, great. So we should get a quad rendering from this, right? It should be pretty simple. Again, NScene has nothing. I'll copy this. This is the vec2 position. I'll copy this, put it here, because really what should happen is this should call draw quad, except the difference will be that we'll kind of do position.x, position.y, and then 0 for that, and then size color just gets forwarded like that. So basically defaulting that to be 0, if you specify a vector, z coordinate will be 0, and it will just flow through the same code, obviously. That looks pretty good to me. So of course we're ignoring position and size, but that's something that we'll tackle in the next episode. That looks pretty good to me. We should try this out, I guess. Let's just hit F5 and we'll see what happens. Okay, so straight away, of course, we get an error in begin scene. That's to be expected because, of course, I didn't call init or shut down anywhere. So if we kind of go back here, what I should do is inside application, this should be maybe down in the 3D renderer. If we look at application and what application does, let's take a look here. So sandbox, where is application? Application.cpp. You can see what that does is it initializes the renderer. And what the renderer should do is also, and let's see what render command init does. That just initializes the API, sure. What this should do is actually call renderer 2D init, right? So that way when we initialize the 3D renderer, because this is kind of like the main renderer, it will also kind of spin off and initialize the 2D renderer. So renderer 2D. .h, and then we don't have a shutdown yet, which we definitely need to have, but when we do have a shutdown, we'll kind of stick that in there. Okay, let's hit F5 and see what happens. Okay, so we get a blank screen with absolutely no square, so let's debug that and see what went wrong. Specifically, I think what I want to do is check out the shader, because if you've got I'm pretty sure everything else is correct. So we are multiplying this by transform, which kind of implies that the transform needs to be set up, otherwise it won't work. So what I'll do, because if that's coming in as 0, then our matrices, our position is not being output correctly at all. So back in renderer2d.cpp, what I'll do is, apart from just uploading the view projection, I'll also upload the transform, except the transform I will just set to glm mat for 1.0f for now. Let's see if that makes any difference. Okay, and there we have our square, which is now, the camera you can see still works. Everything looks pretty good to me. But now we have, of course, the square, which the square color doesn't affect anything because we passed in a constant of red, but I think we'll kind of leave it as that. Okay, cool. So I hope you guys enjoyed this video. It was a very simple look at the beginnings of our 2D renderer. Next time what we'll do is actually make it so that we can control the position and the size, and so that we can render multiple. I mean, at the moment we can definitely render multiple squares, but they'll all be at the same position, at the same size. but the color will be variable. So we'll take a look at how we can set the transform as well to be what it needs to be in the next episode. I do want to stress that this is a very simple approach to 2D rendering. Of course, we are gonna expand on this and make it a lot better than it is right now, but I think it's important, of course, to begin at the beginning and show you guys what a simple 2D renderer looks like and the concepts behind that before we do actually expand and make something a little bit better. If you guys did enjoy this video, please hit that like button. Don't forget to help support the series on patreon.com/thecherno, and I will see you guys in the next video. Goodbye.